STS. STS, go. Prop, go. AVI.
AVI's go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
You're looking at a live view of Falcon 9 at Launch Complex 39A at Kennedy Space Center, awaiting liftoff at 11:50 p.m. Eastern Time. Welcome to our live launch coverage of Falcon 9's 101st launch of the year, the USSF-36 mission, delivering the Space Force's X-37B orbital test vehicle to space. My name is Tyler Lionquist, and I'm a Starlink analyst here at SpaceX.
And I'm Jesse Anderson, a senior...
Launch load has started.
I'm Jesse Anderson, a Senior Production Engineering Manager. Today's mission marks the third time the X-37B Orbital Test Vehicle, or OTV, will take flight on a SpaceX launch vehicle. The last SpaceX OTV mission, USSF-36, launched on a Falcon Heavy in December of 2023. The first flight of the X-37B on a Falcon 9 was the Orbital Test Vehicle 5 mission in September of 2017, which went on to spend 780 days in orbit, breaking the vehicle's own endurance record.
Once on orbit, the X-37B will perform demonstrations and experiments using next-generation technologies, including high-bandwidth intersatellite laser communications and the world's highest-performing quantum inertial sensor ever used in space. This technology is useful for navigating environments where GPS is not accessible.
The X-37B program first launched in April of 2010 and has accrued 4,208 days in operation since then. Previous X-37B missions have tested a wide range of applications, including a demonstration of the spacecraft's ability to alter its orbital trajectory using a novel aerobraking maneuver.
The X-37B orbital test vehicle has also tested technology designed to harness solar energy and transmit power to the ground. It also conducted tests to better understand how to sustain humans on long-term crewed missions to the moon and beyond.
It is an incredibly capable autonomous spacecraft. For today's X-37B mission, weather is currently 10% POV, which is great. That's about a 90% chance of great weather at T0. The range is ready to support. But if for any reason we are not able to launch today, we do have a backup window that opens up tomorrow at midnight. And one last note, we will be closing out tonight's webcast immediately following Stage 1 landing at the request of our customer. Now, the countdown continues. Let's take a closer look at the X-37B and its mission.
That's Falcon 9 on your screen, a two-stage rocket that is 229 feet tall and is getting ready for liftoff in just over 13 minutes. At launch, it produces more than 1.7 million pounds of thrust. And rockets like Falcon 9 don't use all of that thrust just to go straight up. Early in flight, Falcon 9 performs a gravity turn. That is a smooth pitch maneuver that tilts the rocket sideways to build up horizontal velocity. You might hear that call out about 10 seconds into launch as vehicle pinching downrange.
And once the first stage completes its portion of the mission, it shuts down and separates from the second stage. A staged rocket like Falcon 9 detaches the booster to reduce weight and expose the Merlin vacuum engine on the second stage. Stage 2 needs to reach an orbital velocity of about 28,000 kilometers per hour just to prevent falling back down to Earth and to reach orbit. Now that's fast enough to lap the Earth in about 90 minutes.
After stage separation, today's booster will be landing at Landing Zone 2 at Cape Canaveral Space Force Station, and it's going to be returning to Earth for its 6th time. The second stage will take over from there, powered by that single Merlin vacuum engine, also known as the MVAC. With its extended nozzle and optimized design, the MVAC produces about 220,000 pounds of thrust in the vacuum of space.
And at the very top of the vehicle is the payload fairing, a 17-foot wide carbon composite shell that protects the payload during the uphill trip through the atmosphere, and you can see it there on your screen. About 3 minutes into flight, both halves of the fairing will separate and parachute back down to Earth. Many of our fairing halves have seen multiple flights, but today we have one flying for its second time and the other just for its first time.
If recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again. So much of what makes Falcon 9 remarkable happens in those first few minutes of flight, these stages separating. The first stage landing itself on land or on a drone ship in the middle of the ocean, and those fairings parachuting back, all to get ready for another flight to space.
And just at T-minus 11 minutes, Falcon 9 is tracking no issues and our payload is healthy. The Falcon 9 team reported on console at T-minus 2 hours and 15 minutes and began their final checks of the launch vehicle and ground systems. Final checkout of the flight termination system was performed at T-minus 1 hour and 45 minutes.
The chief engineer conducted a technical readiness poll just before T-minus 1 hour. After that, the Falcon 9 team completed a data review of first and second stage propellant checkouts, as well as avionics and guidance, navigation, and control at the T-minus 1 hour mark. At the technical readiness poll, there were no issues, and the team completed the poll at T-minus 38 minutes to proceed with propellant load and launch, and we're expected to finish loading at T-minus 2 minutes.
Now you might be able to hear some of the live rocket sounds from our launch pad. Those pops and hissing sounds are from the propellant loading as well as the launch mount in the strong back that the propellant is flowing through. Falcon 9 uses 2 propellants. The first is RP1, which is a highly refined kerosene, and the second is our oxidizer, liquid oxygen, which is commonly called LOX. An oxidizer is a type of chemical that releases oxygen to mix with fuel and allows it to burn.
The liquid oxygen is chilled well below its boiling point, so that is a much greater amount of mass per volume.
And today's mission is for the U.S. Space Force and is being overseen by Space Systems Command, or the SSC. Space Systems Command is the U.S. Space Force's field command responsible for acquiring and delivering resilient capabilities and groundbreaking technologies to protect our nation's strategic advantage in and from space.
Here's an overview of Space Systems Command's mission.
The ultimate high ground has no ground. The satellites in orbit around our planet provide the critical infrastructure we use to defend and protect the security and prosperity of this world we all share. But space is no longer a benign environment. Adversaries and near-peer nations are actively working to dominate the most critical battleground of our day. At Space Systems Command, the time to act is now. The race is on.
Our adversary is out there. They are going to work every day, trying to work harder, smarter, faster than us. But we are making sure that that does not happen.
The Guardians, airmen, and partners of Space Systems Command are working with unstoppable urgency to innovate and act now, delivering solutions to emerging threats, creating resilient space architectures we can all rely on, especially during times of crisis and conflict.
The fight could happen tonight, it could happen tomorrow, it could happen in a couple of years, but we need to start innovating now, and that's exactly what we're doing.
For Space Systems Command, working faster means breaking from the status quo, exploiting existing space architectures and capabilities in creative new ways, working with commercial industry, innovators and tech startups, and allied nations to exploit, buy, and build. To deliver better, faster, and more affordably.
We are advancing the space architecture that we have up there right now, making sure that it's optimal, making sure that we get new space architecture set up, prototyping, experiments, to ensure that we can outpace the enemy tomorrow.
To maintain our lead in space, Space Systems Command has embraced a new culture, empowering its people to race forward. Speak up and connect with industry in unprecedented new ways.
Our people are agile, they continue our partnerships, they are working collaboratively day after day in order to contribute to the big warfighter purpose.
Space is a team sport. We have to work together to provide integrated, resilient capability and speed in order to fight through any contingency or crisis.
Space Systems Command is moving fast to maintain U.S. superiority in space, running a marathon of sprints, thinking differently, acting boldly, empowering at every level to make space work for us all. At Space Systems Command, space starts here.
If you're just joining us, we're currently at T-minus 6 minutes until launch of the USSF-36 mission, delivering the Space Force's X-37B orbital test vehicle to space. Liftoff is scheduled for 11:50 p.m. Eastern Time from Launch Complex 39A at Kennedy Space Center. Now, next up in the countdown, the Transporter Erector, or TE, will begin to retract away from Falcon 9. That's the large truss structure that you see standing next to the rocket. It's hinged at the base and is connected to the launch mount beneath the first stage.
And first, we'll see the clamp arms open up around the second stage. It's just below the fairing. Then the TE will begin to pivot back, slowly swinging away from the rocket. It will reach full recline by T-minus 3 minutes and 40 seconds. And you may also hear the TE called the strongback. It's the same structure, just a different name. The TE rolls Falcon 9 out to the pad, raises it vertical, and stays connected through the final seconds to launch. The TE provides fuel, power, telemetry, and command connections between ground systems and the vehicle.
So tanks are pressing for strongback retract.
So we're just about 35 seconds away from starting to see those clamp arms opening around the second stage on our vehicle stack. Those clamps help stabilize the second stage during fueling, and they also prevent movement in high winds. Once they are open, the rocket will be fully free at the top.
It may be a little bit hard to see what's around the vehicle, but we should start to see those clamp arms opening up here shortly. Again, they're around the second stage, but
retract has started.
But just below the fairing, and we heard that call out that the strongback, or TE, is going to start that reclining process. Again, those arms are going to open up first. Again, hard to see with those clouds. It looks like those clamp arms are beginning to open up. Again, once they are fully open, then that strongback, or that TE, can begin to recline away from the vehicle. And there you can see those clamp arms moving. And it looks like they're fully open now, so the TE should begin to recline away from the vehicle. It's going to be really slow and slight. It's just going to be a few degrees here. And there you can see it moving on your screen. And a pretty slow process, but just a couple degrees, and then it'll move further away at the T0 mark to clear the way for the vehicle.
Spacecraft is on internal power.
So right now, both stages are nearly fully loaded with about 1 million pounds of propellant. That includes RP-1, a highly refined kerosene, and liquid oxygen chilled to under 300 degrees below zero. Propellant is loaded late in the countdown, and that's intentional. Colder propellants are denser, and denser...
Stage 1 LOX load is complete.
There's a good call out. Denser propellants mean more performance out of the same tanks.
And before any of that propellant flows through, the plumbing and engines are chilled down. That prevents thermal shock and boil off when the ultra-cold liquid starts moving. And you may hear that referred to as engine chill. And we did hear that call out, as Tyler mentioned, at T-minus 3 minutes, that stage 1 liquid oxygen loading is complete. Coming up next will be stage 2 liquid oxygen loading at T-minus 2 minutes.
So at T-minus 60 seconds, Falcon 9 will enter startup. And at that point, the rocket's onboard flight computers will take over. From there on out, the countdown becomes fully autonomous. Then, just inside of T-minus 2 seconds, the 9 Merlin 1D engines will ignite, and once they're at full power, Falcon 9 will lift off the pad and begin its climb to orbit.
And we are coming up on that call out at the T-minus 2 minute mark for liquid oxygen loading on the second stage.
Stage 2 LOX load is complete.
And there it is. That means Falcon 9 is now fully loaded with propellants. As of now, the payload remains healthy. The rocket is tracking no issues. Weather is green, and the range is clear to support our scheduled liftoff of 11:50 p.m. Eastern Time.
Now, you might have noticed those white clouds that are venting from the rocket. That's not smoke, it's actually condensation. As the liquid oxygen warms slightly inside those tanks, some of it boils off, then that gas is vented to manage pressure. When the vented oxygen hits the warm and humid Florida air, it instantly condenses into those clouds. Same principle as your breath on a cold morning, just a much bigger scale.
And we are coming up on Falcon 9 in startup. That's when the internal flight computers take over the launch countdown. The stage 1 and stage 2 tanks will also begin to pressurize for launch.
Falcon 9 is in startup.
There's that call out.
All right, and now we are waiting for the final go from the launch director.
This is the mission director. Go for launch.
We just heard that great call out that we are go for launch. He's given the final go. Let's listen into the countdown.
T-minus 30 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power and liftoff. Go SpaceX, go USSF-36.
Vehicle is pitching downrange.
MOD chamber pressure is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Launch Complex 39A at Kennedy Space Center. Now, in just a few moments, we'll begin to throttle down those engines on that Stage 1 vehicle that you see on your screen in preparation for Max
Falcon 9
Q.
power and telemetry are nominal.
Good nominal call out. Max Q is the period of maximum aerodynamic pressure. This is a critical moment during flight because the combined stresses caused by Falcon 9 accelerating through the atmosphere.
Falcon 9 is supersonic.
And the ambient static pressure are at its greatest point during this moment.
Max Q.
And there's that call out for Max Q.
Now we have several events coming up in quick succession, and we should hear all of these called out by mission control, starting with main engine cutoff, or MECO, stage separation, stage 1 flip, SES-1, start of the boost backburn, and fairing separation. MECO is where we shut down all 9 Merlin 1D engines on the first stage. Then stage separation is when the first and second stages of Falcon separate from one another.
Some great live views there of the first stage vehicle. Stage 1 flip is when the booster uses its nitrogen gas thrusters to flip the booster around. Now, depending on the mission, Falcon will perform a fast or slow flip. Today, the booster will perform a fast flip because it will be returning back to the landing site on land. On Ascent, the booster is moving away from the landing zone at 1 mile every second, so every second counts. The fast flip gets us maximum impact on the forward velocity and allows the booster to orient itself quickly to boost back to the landing zone. Now, second engine start 1 or SES-1 is when we will light that MVAC engine on the second stage for its first time.
Stage separation confirmed.
So we just heard that call out for stage separation, and with
Stage 1 boost back startup.
all right, so with the boost back burn, that'll last about 45 seconds. Meanwhile, we should be hearing a call out for fairing separation in just a few moments.
Fairing separation confirmed.
And there we just heard we had a successful fairing separation. While Stage 2 continues on its journey, the fairing halves will fall back to Earth, where we'll attempt to recover them using our recovery vessel, Doug. Now, the boost back burn is almost complete, and it's going to place the first stage on an optimal trajectory for landing at Cape Canaveral Space Force Station at Landing Zone 2.
Here you can see a view.
Stage 1 boost back shutdown.
View from the first stage, we heard that call out, but also you can see that those engines have shut down on the first stage vehicle. Now it is nighttime over on the East Coast, so it's a little bit hard to see, but we are still seeing a view from the first stage vehicle. We'll see if we are able to get some clearer views as we hopefully will get some light to shine on the vehicle. It's a little bit hard to see, but you can kind of see the grid fins are opening up on the first stage there. And this is a view of our mission control here in Hawthorne. Now it is 4 minutes into today's mission. The next major milestone coming up is almost at the T+7 minute mark, and that's where you should see the first stage's entry burn. To start the entry burn, we will relight 3 M1D engines on the first stage, and that starts with the center engine, known as E9, followed shortly after by a couple of other engines, E1 and E5. This is similar to pumping the brakes to slowing down the vehicle as it passes back through the Earth's atmosphere. Now, we do this to slow down the vehicle due to reduce the re-entry forces, and that helps us recover and reuse the first stages.
So during the entry burn, Falcon 9 is decelerating by firing its Merlin engines, but the vehicle is still moving really fast. This causes it to fly through Merlin's exhaust gases, also known as the rocket's plume, which deposits a layer of soot on the vehicle surface. And that's why our flight-proven vehicles look the way that they do. The soot comes from the carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little bit more and a little bit more on the outside of the vehicle.
We are still a couple of minutes away from beginning that entry burn, and even though we don't have some live views at this moment, you can still check out the telemetry on the bottom left-hand corner of your screen, and you can also follow along on the bottom right-hand corner of your screen. You can see a graphic showing the engines on the first stage. So you can see when we do have that entry burn, we're going to light up those engines. You can see that on that graphic there.
Now, Falcon 9 is the world's first orbital rocket capable of reflight, and reusability is key to lowering the cost of spaceflight, which enables more investments in critical space infrastructure. The Falcon 9's first stage that is supporting today's mission is performing this entry burn for its 6th time, and as we mentioned earlier, one half of the payload fairing is flight-proven, one is flying for its 2nd time, and the other is flying for its 1st.
And we are, again, just a minute away from the beginning of the entry burn. Again, you can follow along with the telemetry. We are waiting to get some live views back of the first stage vehicle, but we can see the speed and the telemetry. It's nighttime, so it's a little bit dark. We don't have some great views, but as there you can see on your screen, again, it's a little bit dark. We got a little light there, but we'll follow along. When the entry burn does come up, it should light up the screen, and we should get a little bit clearer view of the first stage.
It's a little bit hard to see, but you can see the silhouette of the grid fins. We've got 4 hypersonic grid fins that help us steer the first stage as it's returning back to Earth.
We're about 20 seconds or so away from that entry burn beginning on the first stage. Again, this is going to be the second of 2 burns. And there you can see on your screen, the entry burn has begun. And this is a view from a ground tracking camera. And this is a view from the first stage looking aft down at the engines. You can see that entry burn is burning and should be shutting down here shortly. And as you saw on your screen, the engines have shut down on the first stage booster. That completes the second of 3 burns for the Falcon 9 first stage to make its way back to a land landing today.
So in just under a minute, we should be expecting that first stage landing burn. Now, the Merlins on the Falcon first stage are optimized for sea level, and they achieve 190,000 pounds. 190,000 pounds of thrust each during ascent and descent. At liftoff, Falcon 9's first stage has thrust that's greater than 5 747 airplanes at full power.
We are expecting that landing burn any moment. And there it is. You can see the engines have lit up on the Falcon 9 vehicle. Let's watch as Falcon 9 touches down.
And that was the 6th launch and landing for this first stage.
As a reminder, we will not have views of the second stage at the request of our customer. So with that successful first stage landing, we will be ending our coverage of the mission before payload deploy. We'd like to thank the United States Space Force for entrusting us with today's mission.
And we'd like to thank the range for their support, as always, and for all of our viewers tuning in. If you're interested in more launch coverage, head over to spacex.com/launches for the most up-to-date information. And while you're there, check out our new departure board featuring our upcoming launches with details such as mission name, launch and landing site, and liftoff time. And be sure to follow SpaceX on X for updates on our next missions and milestones. We'll see you again soon.